Almost every foot of Illinois once looked like this. In fact, most of the feet between Indiana and Iowa, Minnesota and Missouri. Tall grass prairie. One of the world's most endangered environments and one of its greatest innovators. They're young environments formed only since the last ice age, but in that time, they have learned how to deal with just about any severe weather that the environment can throw at them. Dry, hot, cold and wet, icy, or even fiery. Everything you throw at this place, it seems like it has a long-developed intelligence for dealing with it, even in fall or winter, when aesthetically, prairie might be an acquired taste. It continually bursts my synapses, and today it's going to burst yours too. There's many kinds of tall grass prairie, and many different environments encompassed within the domain of tall grass prairie, but all of them are at least two things. One, treeless or nearly treeless, and two, extremely, extremely dense. A density of life, unlike anything you've ever seen, unless you've seen a tall grass prairie. For the natives that were once the only humans here, the prairie didn't really end until the savanna. And they loved the savannas, the abundance of them. In fact, they maintained them with small strategic fires that burned away small trees and shrub growth, but left the fire-tolerant oaks largely intact and opened up the floor to other more sun-loving plants. The white settlers, they loved the savannas too, but not necessarily for the life there. They called them parks or groves, and they loved them because there was space to build in between the trees as well as farm and graze, but they still offered shade, protection, and lumber within the trees. Pop quiz! How many towns in Chicagoland can you think of with park or grove in the name? Yeah, that's why. Do you see many savannas around these days? Those early settlers, though, had a much harder time in the intense conditions of the prairie, and they couldn't break its soil yet to reach its unprecedented richness. Instead, in the manifestation of destiny, they conquered and exterminated the only other large animals that resided there, that being bison, elk, wolves, and humans. Until an Illinoisan named John Deere came along with his steel plow, followed by stalwart settlers from Germany, France, Norway, and a lot from Germany. Very stalwart. They came and lived off of the prairie's wealth, but their hard-worked livelihoods would become the prairie's doom. You see, these soils are in fact some of the richest in the world. Bezos beware. A kind of silt called loess was dropped here by the glaciers of the Wisconsin glaciation, covering the continent from the Prairie Peninsula of the western Rust Belt to the Loess Hills along the Missouri River. There are other kinds of silts, but loess is the most fertile and famous. With the constant fluctuations of climate, prairies and woodlands volleyed east and west, with prairies once reaching into Virginia and woodlands once reaching into Iowa, until white settlers arrived. And those prairies vanished faster and on a larger scale than any ecosystem ever before and ever since. Along with so much of that loess, then the savannas on the sheltered hillsides were quickly settled for their ideal human habitat. Most of them were gone even before the prairies. The woodlands within the watersheds were mostly fell to build a sprawling civilization. However, more trees than ever were being planted square on the once treeless prairies. Trees from the east. East Coast? Yeah, some of them, but also like further east. These alien species, which we include in a class called invasives, did well enough where we had already destroyed the soil to expand beyond their confines, especially as there was wasted before the plow some millions of acres of thousands of years of work by microbes and bison and fungi and countless plant species. Don't turn this off yet. I know it sounds hopeless, but we must know the wounds to know the healing. That essential groundwork, though, the elaborate soil structure, it was a one-time deal. It required an ice age and 10,000 years of some thousands of plant species and numerous other organisms interacting in order to create it. And all it takes is a little too much pressure or a broad steel blade to destroy that work forever. Like, practically forever. I mean, does anyone have an ice age to spare? How about 10,000 years? We live our every day without acknowledging or confronting the absolute apocalypse that we had wrought upon not just a number of sophisticated civilizations, but the sophisticated ecosystems that harbored them. So let's visualize the destruction, shall we? Stare evil in the eye. See that prairie out there? It's Wolf Road Prairie. For the last 10,000 years it has been. And it's also the largest and highest quality prairie in Chicagoland. And it's 71.6 acres. In the state of Illinois alone, there used to be 21.6 million acres of prairie. Now, what we have of both the prairies and the savannas is 1% of 1% of that 21.6 million. But we're visualizing here. So let's pretend that this 71.6 acres of prairie is 21.6 million acres of prairie. 1% of 1% of this would look like this. 2 average-sized parking spaces. And we can't just create new, genuine tall grass prairie. Not only do we lack the technology, but we simply don't understand quite enough about how they work. However, we can create emulated savannas and prairies which retain some or most of the functions that provide them with all these benefits. And we're going to need to stabilize our own artificial ecosystems in time to save the planet. What I'm saying is we need this for our survival. So let's take a look at some of these functions. You want to know who you're voting for, right? You want to know where they came from, understand why they are the way they are? Well, if we're going to depend on grasslands, savannas, prairies, and their associated wetlands for our survival, then we better understand why they are the way they are. Well, prairies are open, and open land often means bad weather. If trees can hardly survive here, then what can? Well, as it turns out, more than in most places. And all of this because of, not despite, the very temperamental weather that comes with, Great Plains and Great Lakes. As dust and storms and wildfires are hurled across the landscape, rainy summers or mild winters seem like a roll of the dice. This means frequent serious droughts and intense freezings. Such things do not support Midwestern trees, and that's basically why prairies exist. But storms will come, and with nothing to stop them, they come hard. And whether by lightning strike or by native human activity, all of this dry grass, or in the savanna, dry oak leaves, will ignite. And they're ready to. They're asking for it. The dry grass here doesn't easily break down. In the savanna, oak leaves can last years, curling up so that the wind can easily stir them up into the embers of wildfire. Shrubs and small trees that form dense mats, like ash and dogwood in the east, or cedar and dogwood in the west, don't stand up to the fire. Wetlands, they're only really burned to the top of the water, and mature oaks all go rather unscathed. Everything looks dead and gone. But it's not. This whole block right here was burned last winter, and now look at it. It's back. It's thriving. But how? Well, the fire fast forwards the release of carbon and nitrogen into the soil. But that's not the whole picture. First, let's take a moment to think about all that water in the rain. Now, of the many kinds of prairies, we can classify them generally as either wet or dry prairies. Both of them get inundated, and they both handle that flooding in similar ways. Although wet prairies are often assisted by associated wetlands like sedge meadows and marshes, which, bedded in fine silt and filled with thirsty vegetation, can retain and process immense amounts of polluted water, releasing it to the rest of the watershed cleaner. For the true answer, though, to how prairies can handle the worst of wet and the worst of dry, we need go beneath all the grasses and forbs. Well, to get beneath them, we'd need dig at least about 20 feet down, which would destroy the prairie soil complex forever, so we won't do that. But just understand that in order to do all that they do, these plants don't grow up first, they grow down. With most of the prairie plants you see here, before it sends up leaf or stem, it sends down roots. Prairie dock here can grow 10 feet from the ground, but before it does that, it grows 15 feet beneath it. Prairie rose don't look like much, but all in all, it's about 20 feet in length. Not all prairie plants reach this deep, and most of those roots stay near the surface where they're most needed. But all in all, 75 to 80% of a prairie's biomass is underground. With some studies at this very site counting the number of seedlings in a single square foot of dirt in a number of hundreds, the competition is intense. Most of those seedlings won't survive past the spring, but also due to that density, every piece of soil is being shaped by the rootlets of all these plants. In fact, about 50% of the volume here is just air. It's very porous. And in all that space, these rootlets give home to a universe of bugs and microorganisms and fungi that are constantly working and shaping this underground universe all year long. With such porosity, water and air alike can move with ease through the prairie soil. A single rainfall, once it hits the ground, can travel through millions of miles of roots and rootlets, all drinking up the water and catching the pollutants that washed off of our farms and our pavements. And with all that water too, the top growth dying back every year is immersed in a stew of bacteria that softens up all this dead plant stuff and makes it easier for millipedes and roly-polies and stuff to eat it, poop it, and make hummus. I mean, humus. And please tell your kids that's what hummus is made out of. It doesn't taste good. But on a good prairie, that humus is 2 to 3 feet thick. Why not thicker? Because all of those plants and fungi and arthropods are consuming it and turning it back to its base minerals, which can then be taken up by the plants to, build the plants. So now you see why simply applying too much pressure or breaking up the root systems here destroys the soil complex forever. That's why this part of Wolf Road Prairie looks so much different from that part. However, the organisms of a prairie can and will try to rebuild that structure if we give them a place to do so. This is a productive subterranean world, but not just because of what dies on the surface to be decomposed every single year. Even underneath the ground, that impenetrable mat of roots is constantly recycling itself. You see tiny arthropods and fungi and bacteria eat or utilize other parts of the root systems, which thus die and are then made into humus. And humus retains huge amounts of water, which provides the medium, the market, if you will, for trade. An exchange of nutrients starting when the rain hits the ground and lasting sometimes centuries. The timescale is elusive to us until that water is evaporated again. Large animals too, like bison, shaped the land and dictated nutrient flow. Bison follow sort of ancestral paths, constantly following the same areas and digging deep into the soil, like Cumberland Gap deep. Compacting the soil, yes, but also exposing deep underground silts to the surface where they can be organically enriched. They also favor eating aggressive, overgrowing grasses, which allows more wildflowers and forbs to grow, thus encouraging biodiversity. And, of course, they poop a lot. That's what humus is made out of. It's just poop. It's made out of millipede poop, roly-poly poop, bison poop. Get over it. Dip a pita chip in it. It's just poop. But this constant trade extends well beyond the soil and into the sky. No, I'm not necessarily saying that all those dead plants are going to heaven, but in order to build those gargantuan root systems and in order to build all this top growth, there is needed a great magnitude of carbon dioxide. The stuff that's eating away at our atmosphere and warming the globe and causing certain invasives to become super aggressive and causing all kinds of dangerous climate patterns, that stuff. Anyway, in order to build those gargantuan root systems that constantly need to be replenished, and in order to build 15 feet in some cases of top growth, flower, seed, and die every single year, there is needed a gargantuan amount of carbon dioxide, which the plants take the carbon from, turn it into carbohydrates. And they do that every single year. This is like a CO2 vacuum. And all we need to make it happen is a whole lot of seeds, some dirt, a lot of work, and plenty of volunteers, or ideally, jobs. Why the volunteers or jobs? Well, remember those invasive species I was talking about? Our mission is to build or rebuild functional ecosystems. Those which are overtaken by invasive species have their functions reduced to the basest levels. And believe me, It is a lot of hard labor to fight these invaders, and ain't no National Guard coming to help us with it. With our help in destroying the abiotic or non-living factors that support a healthy native environment, invasive species, both local and foreign, from similar climates, be those climates similar before or after climate change, can completely overtake. Native species have evolved together for millennia. They have natural checks and balances on each other. There are parasites that cull overly ambitious natives, flowering seasons that don't overlap, plants that specialize in growing where bison trample, and the mycorrhizal relationships that allow plants and fungi to communicate and collaborate over vast distances. Yeah, I know. We're going to have to make another video on that one. These invasives lack those natural checks and balances, especially when we've destroyed the abiotic factors that would support a healthy community. But if we didn't destroy those abiotic factors, the invasives can help destroy them. Let's use Rhamnus cathartica as our example, glossy buckthorn. The root complexes of buckthorn and many other invasive shrubs lack the ability to create a complex soil structure like a variety of prairie plants can do. Instead, they actually compact the soil structure. And lacking that variety of plants and species means that many ecological functions are neglected or null. For example, humus in a buckthorn thicket is quickly depleted by the also invasive earthworms, which love the nitrogen-rich buckthorn leaves, mineralizing all that stuff before it can be taken up by anything but buckthorn, really, making the soil here pretty much worthless. Furthermore, the lack of fine rootlets in buckthorn only holds the soil together in big chunks that a flood can wipe away like nothing, increasing erosion by quite a lot. Anything that would provide those fine rootlets can't grow here because it's shaded out. Most invasive plants and shrubs are the first to leaf in spring and the last to shed in fall. Even if something did have sunlight here, it would have a hard time germinating because some of these plants, like buckthorn, practice something called allelopathy, where they fill the soil around them with toxins that prevent other seeds from germinating. In a native prairie, bluestem doesn't even bolt until ryegrass has a chance to flower and seed. If that don't sound hard enough, well, these plants aren't even fire friendly. For one, they don't burn very easily. For two, though, by compacting the soil and shading everything out, water doesn't flow through hyporeically. It just collects on the surface. So when Smokey the Bear comes along and tells you to start suppressing natural low-intensity fires, you start creating monocultures like this. I mean, and this stuff doesn't even shed in such a way as to make its own fire fuel, especially since all the earthworms come and eat all the dead leaves before anything else can use them. Remember, biodiversity is essential to ecological health, and these invasive monocultures are far from biodiverse. It's the sheer competition and collaboration that forces so many species to evolve together to perform tasks that we humans cannot do alone. Remember also, ecological health is our health. By creating an environment where those native species can thrive and work together, they themselves will create the conditions that allows even more native species to move in and allows more resources to flow through. By integrating ourselves into that system, we too can contribute to and borrow from those processes. Keyword, borrow. What we take must be given back. But let's say you are a farmer. By having a prairie next to your farm, or even interspersing prairie plants within your crops, you attract all of the same resources that make prairies so rich. Bees and butterflies will pollinate your crops. Decomposers will take care of dieback and waste. Legumes load the soil with nitrogen. All these plants covering the ground will keep the soil wet, prevent evaporation and runoff, and all the dieback is constantly nourishing the soil, creating new, fresh humus. And in time, creating something even similar to the prairie's soil complex will continue to welcome new functions to your land, keeping your food, your water, your air, and your people and family healthy. That's the concept that the STRIPS program is trying to get through to the good people who feed our country. STRIPS is a quickly growing ISU program that tries to efficiently integrate strips of prairie land into people's farmland. This is for all the reasons that we've discussed in this video and the last one, but the incentive for farmers is one of sustainability. Not just environmental, but financial and cultural. Their very way of life is risked by the farming practices that's so environmentally degrading and currently standard. But By treating their farms as ecosystems and integrating but 10% of that land of prairie strips, farmers stand to reduce 44% of water runoff, 90% of erosion, 90% phosphorus loss, and 84% nitrogen runoff, with no effect to crop yield or weed abundance. In fact, crop yield is expected to actually increase because the natural resources that maintain it are self-maintained. Most of the costs are up front too, with them decreasing annually every year until an acre of prairie strip costs only $9 per year to maintain. So much remnant prairie lost, and forever lost. But so much emulated prairie to be made. And we can put them everywhere, like everywhere, on power line easements and railroads and highways and along waterways, in our gardens and our parks, at schools, just about everywhere. And this reconnection of the seamless mosaic that once composed Chicagoland is essential. While a prairie on its own can do a hell of a lot, being fragmented from its associated environments like certain kinds of wetlands means that when it's damaged or degraded, it cannot get the help from the ecological functions that those associated ecosystems provide. Unmanaged prairies often become woodlands without two things. One, frequent fire. Two, defragmentation. We need these little strips of prairie everywhere so that genes and resources from one prairie can get to another. And when I talk about resources, I'm not just talking about the air, the water, and the soil. I'm talking about seeds, pollen, microbiota, and all kinds of flora and fauna. Everything that composes this place needs to be able to get to somewhere better. Maybe this prairie isn't the best environment for a certain plant or a certain bird. They need the ability to move to somewhere where they can be of greater function. Having this ability to exchange genetic material over long distances means that we get greater biodiversity. Genetic diversity is biodiversity. Take care of yourselves and your world, because this planet lives and dies with us.